Good morning, students. I hope all are you well. I am Parveen. Today, I teach you structure analysis. Topic name: slope and deflection in beam. Our topic is slope and deflection in beam. So first we see what is the beam. Beam, it is horizontal structure member which is subjected to lateral force or transverse force defined perpendicular to the axis of member. This is the example of beam, that is the x-axis, and here we put any load which is perpendicular to the x-axis. So we can say this type of structure is beam, right? Due to the load on a beam, any deformation on a deflected curve can be measured in two technical terms. If we see here, we applied load W or any load. It may be uniform load and unit load. This beam is deflected in this shape. Here we see some deflection or some deformation of a beam under a load. So this deformation is measured in two technical terms. First is slope, that is denoted by theta or dy by dx. Second term is deflection, that is denoted delta or y. So dear, now we see slope. It is the vertical angle of a tangent drawn at a point on the deflected curve with respect to horizontal. Here we slope of this point measured angle theta, right? If we draw that tangent on a curve and measured a angle, vertical angle with horizontal, that is slope. Second is deflection. It is the amount of vertical displacement of various points on the deflected curve in the gravity direction. Here we see how much amount This curve is deflected, that is defined by deflection delta. This is a deflected curve. Measure deflection with respect to end horizontal point of beam. So this is deflection of a beam, right? Here we find the deflection and slope for any beam structures. So we find by these equations. This equation is called curvature equation. For defining the value of slope and deflection, the equation to be used is known as curvature equation, which is defined to be EI d square y dx square equal to mx. That sign is positive, right? If you not put, so we can easily understand that is the positive sign, right? So EI is the flexure rigidity. Here E is the Young modulus, I is the moment of inertia, right? Mx is bending moment at any section XX of beam. For the definition of the values for the slope and deflection, the most essential parameter is bending moment function. This parameter is important to find the slope and deflection, right? So this equation important parameter is mx. Mx is bending moment, right? डियर, आपने स्ट्रक्चर 1 में आपने जो भी पढ़ा है तो आपने बेंडिंग मोमेंट ड्राइव करना सीखा होगा. जो भी स्टूडेंट्स हैं जिनको बेंडिंग मोमेंट ड्राइव नहीं करना आता है तो वो स्ट्रक्चर 2 नहीं कर पाएगा. सो प्लीज at your home solve more and more problem on bending moment of simple beam and we easily access other topic, right? So don't waste your time and utilize your time to solving if bending moments for various structures. Taking a simple beam and if you take any book reference, Bhavi Katti and others, Ramamurthan, you can solve many problem on bending moment, right? So we come on topic EI d square y by dx. This equation is derived by these derivations. This equation is called curvature equation. So by the curvature, we easily derive. There, the derivation of this equation not an important part as per exam point of view. If you study more, you can derive by this derivations. You can easily understand, right? If some student learn how we derive, so you can easily learn by this derivation. Here we derive 1 by r, that is the curvature. One by r is the curvature. We know that. So 1 by r equal to dy square dx square. We also know that 1 by r derived by pure bending equations, या pure bending theory. 1 by r also derived by pure bending theory. From the theory of simple bending or pure bending, the flexure equation of curve beam is to be defined as, we know that m by I equal to sigma by y equal to E by r. Dear, this equation is important in civil engineering. यदि मैं कहूं तो ये जो इक्वेशन है ये आपकी स्ट्रक्चर एनालिसिस में काफी इंपॉर्टेंट है, जो कि जो भी आप कंपटीशन एग्जाम दोगे, चाहे वो गेट हो या पीएसयू हो, उसमें इस इक्वेशन से एक ना एक क्वेश्चन बन ही जाता है. सो डियर, फॉर सॉल्विंग मेनी प्रॉब्लम दिस इक्वेशन you should learn. M by I equal to sigma by y equal to E by r. Here M is the bending moment and I is the moment of inertia. Sigma is the bending stress. Y is the distance from neutral axis where we find the bending stress. E is the Young modulus. You can also say modulus of rigidity, Young modulus, right? And R is the radius of gyration. From this equation, we derive 1 by r easily. Here we find easily derive 1 by r in m by I की form में. So from this equation, 1 by r equal to m by E by I. We know 1 by r equal to dy square by dx square. So m by EI equal to d square by dx square. Put equal both equation. Here we find this result. M by I equal to d square y by dx square. So here we taking EI by equal this side. So EI d square y by dx square equal to m. M is the function of x. Obviously, if we taking a moment for some distance for xx section, so we cut a section and taking a moment about the xx section. Clear? So by doing integration both side with respect to x of this equation, here we derive slope equation. If we taking the integration both side with respect to x of this equation, we derive this equation. This equation is called slope equation. EI dy by dx equal to integration mx dx. Again, integrate this equation with respect to x. Here we derive the deflection equation. EIy equal to integration mx dx. This equation is called deflection equation. So both equation you learn, slope equation and deflection equation. Here some method to solving structure member. There are several methods for calculation slope and deflection in the beam member. First method is double integration method. Second method is Maclaurin method. And third method is conjugate beam method. And fourth method is moment area method. Fifth one is strain energy method. As per syllabus of structure analysis, here we study only double integration method, conjugate beam method, moment area method, and strain energy method. So dear, now we start with double integration method. Double integration method. In this method of analysis, the slope is defining theta equal to dy by dx equal to integration mx dx. As we derive previous equation of slope, we can see here ei is not used. It is the limitation of double integration method because ei is the constant for beam structure. You can also say it is the limitation of double integration method. If ei is not constant all through the span of beam, we can't use double integration method, right? And deflection is double integration of mx dx. As we see previous equation, ei dy by dx integration mx dx. Here not use ei due to the limitation of double integration method, right? So we learn about the limitation of double integration method. First limitation is this method is applicable for the case of beam where expression for the bending moment function will remain constant for throughout length of beam. Means if we see this beam here, any load applied at end of beam W, here the bending moment function variation is constant all through beam. So this beam is solved by double integration method because here bending moment function remain constant for throughout length of beam. If we see second beam, this beam is acting W1 and W2 unit load at any distance from the fixed end. Here, if we find the bending moment for this beam, the bending moment not be constant for this beam. Here I write m1 equal to fx and m2 equal to fx1. So m1 is the function of x and here m2 is the function of x1. So in this beam, bending moment is not constant. Therefore, we can't derive slope deflection for this beam by double integration method. Second limitation, the double integration method can provide the solution for the problem with the uniform varying load, but not the case of varying load problem. Here, this beam is acting uniform varying load, UVL, uniform varying load. So this beam is easily solved by double integration method. If we see second beam, this beam is acting UDL and unit load. Due to this variation of load, the bending moment is variation all through span of beam. So this beam is not solved by double integration method. If we see this beam, here we applied UDL, uniform distributed load, over a span. So here easily we find slope and deflection by double integration method, right? Third point is the double integration method can't provide the solution for the problem non-prismatic beam. If we see this beam is the non-prismatic beam. Here, for half span, the EI value is 2EI, and for half span, the value is EI. It means the variation is EI. Here 2EI and here EI. So that's why we can't use double integration method. I already tell for double integration method, EI will be constant all through of span of beam. If we see second beam, this beam is also non-prismatic beam. Here EI is variation. So that's why Mx is not constant, right? If we see third beam, here we see This beam is the prismatic type. You can say AI constant for whole through span of beam. Here, this is last topic of our video. We see some important point today video. You focus on that point and learn. You you know about the slope and deflection. I repeat it again. It is the vertical angle of a tangent drawn at a point on the deflected curve with respect to horizontal. Second, deflection. It is the amount of vertical displacement of various points on the deflected curve in the gravity direction. Here we learn curvature equation. This equation we learn EI d square y by dx square equal to mx. This equation is derived by this expression. So you can see from this equation we derive 1 by r equal to d by x square by dx square. Right. So this part is important part. This relationship we learn m by I equal to sigma y equal to E by R. That equation is derived from theory of simple bending or pure bending. So we learn from above equation, from above curvature equation, we derive two equations. First is slope equation, EI dy by dx equal to integration mx dx. This equation is called slope equation. And second equation is deflection equation, EI y equal to mx dx. This equation is deflection equation. So for double integration method, we learn theta equal to dy by dx equal integration mx dx, or deflection that is equal to mx dx, double integration mx dx. This equation derive above equation, from above equation, this one and this one. Here not use EI because EI is constant in double integration method. So in a questions, if we solve question on double integration method, these formula are used to find the slope and deflection. So dear, in next video we come with some solving problem. So before that, you learn today video some basic point. Once again I repeated, those students not know about bending moment, they come with more and more practice with bending moment, then after we solving questions. If you have any problem regarding this video, so you can contact at my contact details, or you can also email at my email ID. My email ID is Parveen, Parveen double ENANSHI @gmail.com. You can also WhatsApp at a number 8053822029. Thank you guys.